Greetings everyone, I'm Tan Liang Jun, a year 3 student currently studying Biodiversity Conservation and Management, and I'm from Faculty of Science and Marine. I'm currently taking the course FEI 4302, which is Optic and Laser Technology. And firstly, I would like to introduce to you all my title of the presentation, which is the ProSpectro. So, what's a ProSpectro? A ProSpectro is a self-made or handmade simplified spectrometer that used to take in light and break light wave into its spectral components. So, what's a spectrometer? A spectrometer means the spectro means the spectrum, and the meter means the measuring device or instrument. So, I'm using this as my instrument of measuring the light wave. It is used for measuring wavelength of light of electromagnetic spectrum. So why am I designing this ProSpectro? It's because this ProSpectro I designed is nearly the same concept as the spectrometer, but not measuring the wavelength by using computer software, and it's just using phone applications that I can download from Play Store and App Store. The design I made was small and convenient, so I can just stick on my smartphone and just use the camera to capture the spectrum when I point it towards the light source. I'm sure you're curious, how does this thing, the ProSpectro, works? This ProSpectro works through the diffraction of light wave and the gratings on the compact disc, which is the CD. I'll explain the theory behind later. Let me tell you how the ProSpectro functions. Firstly, the light will pass through the opening slit of the ProSpectro, which is the narrow opening of the ProSpectro, and this narrow opening will determine the amount of light that is able to enter the instrument, and then the light will go through the dark and fully covered tube until it reaches the CD, which I stick in front of this ProSpectro that act as a diffraction grating. The CD then separate the lights into different wavelength of spectrum and also different colors that will show that can be seen inside the black wall of the ProSpectro. So take a note here, the narrower the opening slit, the better the resolution of the spectrum you get. Next, before explaining the theory behind this ProSpectro, let me introduce you the main character of this ProSpectro, the compact disc, or we call it CD or DVD, the digital video disc. Why is it so important to the ProSpectro? As I mentioned before, the CD acts as a diffraction grating that can diffract lights into their separated spectrum. So, what is diffraction? Diffraction is meant by the phenomena that occurs when a wave encounters an obstacle or opening, which is the bending of wave. Diffraction is meant by the phenomena that occurs when wave encounters an obstacle or an opening, then the bending of wave occurs. And what is gratings? Gratings is the evenly or parallel arranged space in a substance. So, why CD can act as a diffraction grating? Okay, for information, this CD is the one I haven't removed the foil on top of it, and after removing, this is the one we can see. So, why CD can act as diffraction grating? This is because CDs has a lot of very small bits arranged parallelly around the CD track. The small bits cannot be seen by our naked eye, but it can be magnified to 1,000 on an electron microscope. This is what we can see on the CD surface as I have drawn. You can see the parallel lines on top of it. So what do these small bits function in a CD? The digital information of a CD, which is the music or the data, are encrypted in the CD in these small bits that form closely spaced rows between them. I have two examples of the surface of the CD. One is the CD before it is encrypted with any data. The line on it is very long. The parallel line is long, and another one that is encrypted with data. The line is short, and you can look, there is more space between them. So consider a small part of a CD. As you can see here, the small part I have drawn. Each groove sends out a light wave in all directions, and the outgoing wave is the result of the superposition of all these individual waves. And you can see from the ProSpectro, a rainbow color of spectrum. Now we know that the gratings on the CD, the spacing that is responsible for the wonderful colors reflected by the CD, which work just as a diffraction gratings. For information, I'm using DVD as a diffraction grating because a DVD can hold 7 times much data as a CD. The tracks are close together, and this will cause the diffraction of spectrum will be nicer. After explaining so long about the theory of the ProSpectro and how it works, I'm sure you are curious of how I make this ProSpectro, but it will be more easy and time saving if you go and have a look on my slides. What is meant by a continuous spectrum? As you can see from the spectrum of the sunlight and the candle flame, the spectrum is continuous and there's no breaking or dark lines between the spectrum, so we call that a continuous spectrum. For continuous spectrum light source, we call it an incandescent light source. It is very similar to the light source come from our house light bulb, which there's a wire inside the light bulb. Next, for the fluorescent tube, the spectrum you can see is discontinuous. What is meant by discontinuous spectrum? So you can see from the fluorescent tube spectrum, there is a dark portion in between the color spectrum. Why this happens? This is because when the fluorescent tube emits light, an electronic charge in the tube passes through an ionized gas, and the gas absorbs some of the wavelength emitted by the light, causing the black part separated in between, and we call this the emission spectrum. For information, the light source that we see through the transmissive gratings showing two diffracted orders. Let's refer back to the spectrum of the sunlight or the candle flame. You can see the middle part of the spectrum, which is the light that direct transmitted through the gratings. We call that the order m equals to 0 as it is not diffracted. And for the left and right colored spectrum, it is the first positive and negative order, which m equals to +1 or m equals to -1. Colors with increasing wavelength from blue to red are diffracted at increasing angles. So, extra knowledge to you, the wavelength of every spectrum is different. The longest wavelength is red and the shortest wavelength is violet. As the wavelength of the red spectrum is long, so it diffracts at a larger angle, and we can see the red spectrum is located more far from the violet spectrum. The violet spectrum has the shortest wavelength, so it will be diffracted at a lower angle and vice versa. As you can see throughout the long spectrum, the color part is actually caused by the constructive interference of wave, while the black part that we can't see anything is caused by the destructive interference. And my presentation is coming to an end, so I will share with you my experience of building and designing this ProSpectro. Firstly, by designing and building this ProSpectro, I actually gained a lot of knowledge of the ProSpectro and how it actually works to get a nice spectrum. You have to be very careful on it. You need to take the picture on the correct angle so you can obtain a very nice spectrum. Secondly, I just only got to know that what is continuous, discontinuous, absorption, and emission spectrum after I made a lot of research on my spectrum that I've obtained, and I just know that fluorescent tube that just everywhere in the house can emit a nice emission spectrum. Besides gaining knowledge about the spectrometer or ProSpectro, I have just gained my handcraft skills, although it is not as nice as I expected, but I'm quite satisfied with the result I got, and it is quite perfect. And last but not least, I would like to thank Dr. Fariza for guiding us throughout the project ProSpectro and patiently giving us explanation about what we confuse, and also letting us to do such an interesting experiment. I hope you like my video. Thank you.